Hi guys, welcome to my channel. So in this video we are going to do a revision about more concept. This is chemistry. Okay, so more concept, it comes every year. So it comes every year. Okay, now the most important thing to understand about more concept is we have to look at first of all the definition. Okay, so the definition, you have to define what is a mole. So to begin our lesson, so if you are watching for the first time, you can follow me on TikTok, also on my Facebook account, and also on my YouTube channel. If you want to learn one-on-one, where we can learn via Google Meet as well as the Zoom. So you can just call us on the following number. So which is 096446 46 02. Sorry. So 460218 or 076 014 9581. Okay, you can just give us a call on those numbers. So we look at for today, we are going to define. So like I mentioned earlier, define what is a mole. Then also look at how to calculate how to calculate the number of moles. Okay, so this will be just our outline for today. We'll be just going slow by slow. So how to calculate the number of moles given the mass. Okay, so to begin, so a mole, just define that this is the number of particles, in a substance. Okay, so this is how we basically define the mole, or rather a mole. So the key point is the number of particles in a substance. So you might be dealing with this substance. This substance can be so could be number one, single element. Okay, so this substance could be a single element, and then also the substance could be a compound. Okay, could be a compound. So you have to be able to know what is it that I'm dealing with. Is it a compound or just a single element? So now once you begin to understand that, then now you have to look at what is the formula of finding the number of moles. Now before I dive into that, when you have the periodic table, okay, when you have the periodic table, okay, so the periodic table. So now, for instance, I just hope and believe that you are you have an understanding of what a periodic table is. So meaning, for example, I can give you, a periodic table contains elements. So I can pick sodium. I can pick sodium. Okay, so now this sodium on the periodic table is written as A, okay, and then it has got numbers 23 on top and 11 at the bottom. So now when it comes to the more concept, okay, we now deal with the numbers, or rather the number on top of this element that we have on the periodic table. So I have to be very careful when it comes to that, okay? Now, from there now, what we can say is that's the thing. So you can only find a single element on the periodic table. You can't find a compound. So what's going to happen now is you have to be able to differentiate, okay? If you're dealing with a single element like sodium, or maybe you can have a compound, let's say for example, carbon dioxide, okay, carbon dioxide. So when you look at this, carbon dioxide is not found on the periodic table because this is a compound, okay, this is a compound. It's a compound. Okay, so a compound cannot be found on the periodic table. So then what we do is when you have something like carbon dioxide, okay, like that. So then what you do is you can separate them by identifying to say, okay, oxygen has 2 atoms multiplied by, now for oxygen, we know that oxygen is just a single element that I can find on the periodic table, meaning I have oxygen like this, so it has got 16, it has 16 on top and also 8 at the bottom, okay? So then I'm going to say in this carbon dioxide, there is 2 atoms of oxygen, and then now what is the mass, okay? So I'll be dealing with the mass, meaning the number on top of that element from the periodic table. So this is going to be 16. And then I have for also carbon, we know that carbon has something like this. It has 12 and 6. So now I'll pick 12 because that is a mass of carbon. And there is, in this carbon dioxide, there is just 1 carbon. So it's 1 times this mass number right there, and that is 12. Okay? Now, once you do that, so what you are going to get now is you have 2 times 16, simply 32, and then 1 times 12, simply 12. And you now add these numbers, okay? You add these numbers. So 32 plus 12, you're going to get 4. Okay, so now this is the mass of this compound. So basically, this is what you'll be dealing with in terms of is the number, is a substance, an element is a substance, a compound. Okay, so you know that in this carbon dioxide, I have 2 elements, so oxygen and carbon. Okay, so now having understood that, then what is the formula for finding the number of moles? Now remember that 1 mole, okay, 1 mole of any substance, particularly an element, is equal to its mass. It equals to its relative atomic, so relative atomic mass. Now what this means is that if you have 1 thing of the sodium, Okay, 1/3 of the sodium so 1/3 of this sodium, okay, will contain as much as 23. So when you go to the periodic table, just to give you a hint, so sodium is 23 and then 11 at the bottom. So meaning 1/3 of this sodium contains 23 grams, okay? Contains 23 grams, which is just the relative atomic mass. So from there now, we are simply saying that 1 mole of anything is equal to its relative molecular mass. So then therefore, the formula now that you can use is now N equals to M divided by relative atomic mass. Now we have to be able to understand this formula is now working for when the substance that you are dealing with is now a single element. Okay? So the substance that I'm dealing with is a single element. Okay, single element. Now, if I'm dealing with a compound, then instead of having this one, then we can say O number of moles equals to mass given over Mr. Okay, so meaning we have to be able to differentiate what is the meaning of this and what is the meaning of this. So when you have this as Mr., that is relative molecular mass. So remember that AR is simply relative relative atomic, okay, relative atomic mass. Now this mass is always in grams because we are dealing with something that is very small, and for this one, Mr., we are looking at it in terms of relative molecular, okay, molecular mass. Okay, we need to be able to differentiate the correct thing. So from there now, use this one in the formula if you are, the substance that you are dealing with in the question is now talking about single element. Use this one if your substance in reference is a compound. So therefore, number of moles equals to mass over AR. So this assumption is that this formula will only work if I'm dealing with a single element, or number of moles equals to mass given over Mr. Okay? So this one I'm dealing with a compound, and this one I'm dealing with a single element. So let us now look at just 2 examples. So we have one example for the single element and one example for a compound. Okay. Okay, so we have worked examples. So calculate calculate the number of moles in the given substances. Okay, so now let's calculate the number of moles in the given substances. So what's going to happen is you're going to have let's say you're going to have 10 grams of sodium, and B, you're going to have let's say I'm going to have 5, okay, 5 grams of carbon dioxide. Okay, so now, so start with this one, 10 grams of sodium. Okay, so remember, so you have to ask yourself, is a substance in the question a single element or a compound? So when you look at sodium, sodium, it is a single element. Okay, it's a single element. So in the chemical form is this, it has 23, 11 at the bottom. So now this is a single element. When you check it from your periodic table, you'll be able to see that this is appearing on the periodic table. So now the mass of sodium is 23. Okay, now what's going to happen is this, our information that we have. Okay, so N means the number of moles, that's what you're looking at, and then M is just a given mass, and in the question it is just 10 grams. So 10 grams, okay. So we have 10 grams. Then what else do we need? We need, since it's a single element, so our relative atomic mass is just going to be this number on top of our sodium, which is 23 grams per mole, okay? Those are the units. So once you have this piece of information, now it becomes very easy for us to now continue with the question. So now we're going to say N equals to M over AR. Then our M is just 10 grams divided by our AR is just 23. So 23 grams per mole. Okay. So meaning this is gram cancels out. And now when you divide that, you're going to get so now 10 divided by 23, we are getting 0.43. So just get your answer correct to 2 decimal places, so 0.43. So we have it as 0.43 moles. Okay, so that's the answer. Those are the number of moles that are contained in this mass of sodium. Okay, Now we move on to the B, where now the substance in the question is a compound. Okay. So we have been told that our number of moles is what we're looking for, and then the mass given is just 5 grams, and also since now the substance, okay, the substance is a compound, okay, it is a compound. So because it is a compound, then you have to be very careful. So what's going to happen now is we'll say the relative molecular mass of this carbon dioxide. Okay, so we have is carbon dioxide. Okay, so there is a 2 there. Okay, so what you do is to find the combined mass, the total mass for the two elements that are contained in this carbon dioxide. All you have to do is just do this. Okay, so we have 2 atoms of oxygen in this carbon dioxide, multiply by, go to the periodic table, look at oxygen, find the number at the top of oxygen, that is 16. And then for carbon, there is just 1 carbon. And then do the same thing, go to carbon, look at the number on top of carbon, you just find that it is 12. And then from there, when you multiply, you get to 32. And then 1 times 12, you just get 12. Now, once we now add the two numbers, we get 44. So that's 44 grams per mole. Okay. So that's our relative molecular mass for the compound. Okay. So we have it as 44 grams per mole. So now from there, we can now say the number of moles equals to the mass given divided by mR. So you can now look at the first one, we use AR. You have to be very careful when it comes to the formulas, because the examiner might actually penalize you because you are saying two different things. Okay, you might use this one, mR, in the sense that the substance in the question is a single element, which is wrong. So make sure that you check out the formula. The formula is correct based on the question. So from there now, we say this equals to, now substitute 5 grams divided by relative, which is 44 grams per mole. Okay, those are the units for the relative molecular mass, grams per mole. So from there now we can say that the G cancels out, and what you're going to have now is, now we're going to have is 5 divided by 44. So we're going to have an answer is 0.11. Okay. So now, therefore, the number of moles is just 0.11 moles. Okay. So this is a number of moles. So this is where we're going to end our part 1 of the mole concept revision. So thank you so much for watching. Remember to support me, subscribe, like, and follow my account in TikTok. And thank you so much, and I'll see you again in the next video.